Everyone. Today I was having a quick discussion with one of my friend who is actually really interested in this tutorial series, and he just reached out to me with one very valid question, and then I thought that I should just build a small and sweet video on that so that I can explain, because it may happen that a lot of you guys are having a similar question in your mind and similar kind of confusion, right? So far, we know that we have integrated, PDF, URLs, SQL and NoSQL database, CSV and REST API data, which is in JSON format. And what we did, we just created a chunk out of it and just loaded to the vector database. But here, when it comes to the time series database, we are not going to take this approach. Why? Because the way time series database actually stores the data, that is more of just capturing the trends and the pattern for every moment of time, right? So before I just explain the main feature of time series database, I would like to first just go through the standard logic or the flow which we have been following so far. Whenever we have a data source, irrespective what kind of data source we have integrated, PDF, URL, SQL, relational database, NoSQL database, CSV, what we did, we first load the data, create a chunk, create the embedding with the embedding model, and just load it to the vector database. And then, whenever questions comes in, we always just get the context based on the vector similarity along with the re-rank model to just increase the accuracy of the context. Once we have a proper prompt with the context of the user query, then send it to LLM and we get the response, right? Which you can see on the screen. But in time series database, this is not going to work. Why? That we're going to just talk in a next slide. But the approach which we're going to take here is whenever user is going to ask in a natural language processing, he will be asking, why do we have such a spike in our service? What kind of trend is there? What kind of probability of failing? So we are just actually observing the trend. So it's a temporal data where the data point for every moment is really important, right? So the very first thing what we're going to do is we are going to just have a query parser where we are going to understand what kind of question user is asking. And based on that, we are going to create a time series database query. And once we have a query based on the question user is asking, which is a challenging and the interesting point, how we're going to do that, I'm working on that. Probably it should be out in a day or two. So once we have that query done, then we will be able to extract the data. How the data looks like in time series. I have already explained that multiple times. This is how the data looks like, right? In InfluxDB, we have an option. If you just come here in a graph and if you just click on table, this is how the data gets stored. And the timestamp is really important here, the start and the stop and the time, right? And the way data is being stored, if you just look at the line protocol, this is how the data actually gets stored, right? So since time is very important, if we are going to just have a chunk, right, then definitely we can miss out the very important trend and the pattern, because the data which continuously we are storing in the time series database, it has a correlation, between the next consecutive data which is coming in the time series database, right? So once we have the query created based on the user asked question in a natural language processing, we are going to run that against the InfluxDB, get the data out, and then we have to format that result so that we can build a proper context. Probably we can take the help of a vector DB, but that vector DB data is not going to relate it to time series data, but that could be something else, which we felt probably we just built some additional database in a text format with the log messages and all, which can be combined. But this this time series data is not supposed to be put in a vector database. And I'm just going to talk about why we cannot do that. So once we have that, then we can just feed into the LLM, and then, LLM is going to provide the response, right? So now you can see with this diagram on this screen, you can just understand the major difference, right? Now, what are the main characteristic of the time series data which we store, right? It's temporal in nature. What does it mean? It means that, every data point has equal value as at what point in time it is being stored in a time series database. So time is really, really important, and this database is specifically designed to just capture the data point at the each and every moment so that the trend and the correlation, the pattern can be understood with the data, right? So that is what the second point is. Meaning in pattern and correlation is most important. It's the heart of designing a such database. Volume and the granularity. We know that we are storing a data in microseconds, milliseconds, right? So data size is going to increase very rapidly, right? So these kind of database are designed in a way where it can easily handle the granularity of the data and the volume, the kind of volume we want. So if we just try to convert and put every data points into vector database, that is going to be very expensive, and we should not be doing that. That's the major reason why we should not be putting the time series data to the vector database, because it's not only putting a data, but when it comes to extract the data, that is also going to be very expensive and very complicated. Similarly, the analytical and the semantic question. So in time series data, we ask a very analytical kind of question. We are not asking a very subjective question. We are having a very objective kind of question, we are trying to just look for the patterns, and the correlation between the data. Right. So basically, what are the major, takeaway? If I just wanted to summarize, my complete, explanation for this video, InfluxDB is great at handling the volume and executing a temporal tag-based queries. It's very important. We have to keep this in our mind, right? Whereas the vector database is great in storing and retrieving a documentation, which we have already seen with the other database. And once we are done with this time series database, integration, then you will understand the first point as well. And the third and the last one is large language model is great at understanding the language, synthesizing information from the structured and the unstructured data. Once we create a proper context with the time series data, right, and whatever information we have put it in a vector database to just support, whatever, operations monitoring or the system monitoring we are trying to, if we have a very good documentation from the log messages in our vector database, then we can combine the data points which we have in in our time series database, which can give us the pattern and the correlation along with, the language, along with the log message understanding. Then, LLM can synthesize that information and give us the proper response where we can predict, where we can, monitor the system more intelligently. I hope this clarifies, the doubt. If you are also having a similar doubt, like why we have changed the approach when we are integrating a time series database as compared to the other data sources. If you have a similar kind of question and if you are confused on any point, you can always ask me a question. You can send me an email, or you can just put, your queries in the comment section. I would love to answer that. So thanks for watching this, and stay healthy and keep learning new things. And if you really like this video, give a thumbs up. And if you haven't subscribed for my channel, please subscribe for my channel as well.